This video is going to talk about the law of sines. The law of sines will allow us to solve oblique triangles. And when I say solve, I mean find missing angles and missing sides. And when we talk about oblique triangles, those are the triangles that do not have any right angles involved in them. So here's an example. You'll notice that we have this triangle where we labeled each of the angles capital A, capital B, and capital C. So when you use a capital letter, that denotes an angle. When you use a lowercase letter, side A, side B, and side C. So lowercase letter stands for sides. The formula is written right here. It says it says A over the sine of A equals B over the sine of B and equals C over the sine of C. More than likely, I tend to flip this formula upside down and use it that way. I usually will write it like this: the sine of A over side A equals the sine of B over side B equals the sine of C over side C. And we don't use all three of these at one time. We write a proportion to equal fractions, and we solve by using 2 out of the 3. And the way that we'll use this is we'll use this when we are given an angle and its opposite side. So for example, if I knew what side or angle A is, and I knew what side A was, I can then use this formula, find then the pieces that I don't know. So let's take a look at an example where we are using the law of sines. Writing down the information that we have: 120 degrees, 45 degrees, and this side C was 20. So let's first identify what we need to find. We need to know what angle A is. We need to know what we need to know what side A is. We need to know what side B is. So those are the 3 missing things from our triangle. Right away what I notice is I know 2 out of the 3 angles. So if I want to find angle A first, I recognize that there's 180 degrees in a triangle. If I subtract what I know, which is angle B and angle C, I'm going to end up with 15 degrees left over for angle A. So now I have this angle side opposite relationship where I can go ahead and find the 2 missing sides, either A or B. Let's say that we want to try to find A first. So because you know angle C and side C, you have to use that. So the sine of 120 over side 20. And if we want to find A first, we'd have to use the sine of A over side A. So cross multiply. Cross multiply there, cross multiply here, and set equal. To solve this, we would want to get rid of the sine of 120, so we would divide by the sine of 120. Now when I type this in my calculator, I want to make sure that my calculator is in degree mode. If it's not in degree mode, I'm not going to get the right answer. So typing it in, I end up getting 5.97, so we'll round that to 6. So side A was 6. Now let's find side B. So using the law of sines again, I'm going to stick with 120 and 20 because that was the information I was given. And this is a rounded answer again, so that's why I want to stick with the sine of 120 over 20 and set it equal now to the sine of 45 over side B. So when we cross multiply here, B sine of 120 would equal 20 times the sine of 45. Again, we would have to divide by the sine of 120. And this time we would end up with 20 sine of 45 divided by the sine of 120. 16.3 if I round. It's always a good idea to check when you are done. Check to see if the largest angle, which is C, is across from the largest side. Well, 20 is the largest side, so that's good. Check to see if the smallest angle is across from the smallest side. Again, it is, so that's good. And finally, the middle angle, which was 45, is across from the middle side length of 16.3. If you notice that that's not the case, well then your triangle doesn't exist that way, and you're going to have to go through and make adjustments or figure out where you went wrong. Alright, so taking a look at the next problem, this time I'm given A is 60 degrees, side A is 9, and side C is 10. So I have this angle side opposite relationship, so I can use the law of sines. Let's first write down what we need to find. I need to know angle B and angle C, and I need to know side B. So, first thing I have to find is I have to find angle C, because I know the sine of A, which is 60, over side A, and I know side C. So sine of C over 10. So solving this, we would get 10 sine of 60 and 9 sine of C. This time again I'm trying to find angle C, so I've got to get rid of the 9. So I'll divide by 9. But that will leave me with the sine of C. So 10 sine of 60 divided by 9 gives me 0.9622, and the decimal keeps going on. I don't want sine of C. I want to get rid of this sine by moving it over. And the way we move it over is we take the inverse. And so when I take the inverse, I'd find that angle C would be 74.2. Now here's an issue that we'll run into here, is that when I typed in my calculator the sine inverse of 0.9622, it's giving me the first quadrant angle. But I know that sine is positive in the first quadrant, and it's also positive in the second quadrant. So I have the possibility of getting two different angles from this sine. So the second quadrant angle could also be, if I take 180 and subtract 74.2, it could also be 105.8. So sometimes we have the possibility of getting two different triangles. So what I have to do is check to see if this will work. Well, if I put 74 degrees in here, 74.2 and 60, I have enough left over for an angle B. In other words, I haven't got up to 180 degrees yet. Likewise, if I say that this could also be 105 and not the 74.2, then 105.8 plus 60 still gives me enough left over for an angle B. So this is where I have the possibility of two different triangles. So I'm going to have to also say that angle C could also be 105.8. So now I'll have to go through and find angle B when C is two different angles. Find the side C when C is two different angles. So let's find angle B first. So if I start subtracting the angles that I know, when C was 74.2, I'd end up with 45.8 as angle B. Or when C was 105, so we would find that angle B now would be 14.2. And again, these are all degrees. So now let's try to find side B. So if I'm going to try to find side B, let's use 60 and 9 because that's the information we were given. And let's first find side B when angle B is 45. So it'd be sine of 45.8 over B. Cross multiply. And we would have to end up dividing by the sine of 60. So 9 sine of 45.8 divided by the sine of 60 gives me, when I round it, 7.5. So B would be equal to 7.5. Or, if I use the information where B is 14.2, see me write that up here, I would say the sine of 60 over 9 equals the sine of 14.2 over side B, which is what I'm trying to find. So we cross multiply. We would still divide by the sine of 60. But this time we would end up with 9 sine of 14.2, then divided by sine of 60, 2.5. So again, let's check to see that this works out. So, using, let's see, first off, I use the 74, then b would be 45.8, and this b would be 7.5. Largest angle across from largest side, so that would be for the c's, good. Smallest angle, which would be b, smallest side, good. Middle angle, middle side. Alright, what if I change now to using b as 14.2, c is 105.8, and b as 2.5. Largest angle, largest side, good. Middle angle, middle side, good. Smallest angle, smallest side. So really what I have here is the possibility of two different triangles. Here's my answer up here. And the question that will always occur when I'm doing this is, when do I have to look for this possibility of the two different triangles? In other words, when did I have to recognize that this sign occurs also in the second quadrant? I have to do that whenever I'm given one acute angle. Okay, and that's what that says down here. When I'm given one acute angle, I have to go back and check for that possibility of two different triangles. Notice that I started off with one angle and two sides, and the angle was acute. So since this angle was acute, I had to go back and check for the two different triangles that were possible. Again, when you're given one acute angle, always check this angle here to see if it will occur in the second quadrant, and if you have enough left over when you add up the angles to get to 180.